Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concept related to electric vehicle and hybrid electric vehicles. In the previous tutorial, we have seen the concept related to pre-charge circuit and how the pre-charge circuit works and where the pre-charge circuit can be used. In this particular tutorial, we will be having a look into how the pre-charge circuit is being implemented in MATLAB Simulink environment. We will also see when we will be using the pre-charge circuit, then what is the current when we first time starting the battery to the load, means connecting to the load. Without the pre-charge circuit, like how much current we are getting. So in this case, we will have a look into the same. So this is the pre-charge circuit that we have discussed in the last session. Let's have a look into the Simulink model. So this is the Simulink model that we have, and as you can see, there are multiple components that are present. So if you refer back to the original diagram over here, so you have this high voltage battery, which is this one. So this is a 400 volt battery, which we are currently using for this scenario. Then we have pre-charge contactor. So this is the pre-charge contactor that we have. So this is basically a switch, and when this switch receives a signal of 0, then it is open, and when it receives a signal of 1, then it is closed. So this is the pre-charge circuit, and we also have a pre-charge resistor. So this is the pre-charge resistor, which is this one, which is of 50 ohms in this case. Along with that, we do have this positive contactor. So that is present here. This is the positive contactor, and this will be always closed once the pre-charge operation is complete. Next is the negative contactor. So negative contactor is present here, and then we have the capacitor, load capacitor. So load capacitor is present here. So this is the load capacitor, and we will be measuring the voltage across the load capacitor only, because this is the load area, and whatever the voltage across the capacitor, as the load is connected in parallel. So in this case, we will have the same voltage as these are connected in parallel. We also have the load resistor and load inductor. So if you see here, so we do have this load resistor and load inductor. Resistance will be 1000 ohms, and this inductance will be 1 millihenry. And for the capacitor, we do consider 6 microfarad as the parameter. To solve this entire circuit, we do need the solver equation, solver configuration. So to solve this entire circuit, we do need the solver configuration. And here we are setting the voltage as the input for the so here basically this is a sensor, not as the input, but this sensor. So we are having a voltage, so that is the voltage that we are sensing. Along with that, based on this voltage, we will also take some necessary action. So because of that, we need to measure what is the voltage actually we are having. Along with that, we are also measuring the capacitor voltage. So through this, we will be doing the. So as we seen already, there are multiple stages that we have. So the first stage is all switches open, negative contactor closed. Then we do have negative contactor closed and the pre-charge contactor closed. And then we do have both the contactor closed as stage 4. And in the next stage, we have the pre-charge circuit open. Pre-charge contactor now got open. So this entire process we will be implementing. So first we will see what happens with the pre-charge circuit, and next we will be seeing what is happening without the pre-charge circuit. So in the first stage, we have this as 1 and this as 0. So we will open the main switch, positive one, and the pre-charge contactor will be closed by default, and the negative contactor will be also closed, so that we will make the current flow. So in this case, if I just press on the step button, then you can see multiple readings over here. So this is the reading for the current in the circuit that we are getting. So you can see with the help of this pre-charge circuit, you will be getting very less amount of current. When we remove this pre-charge circuit, then how much current we will be getting, that you will also be able to see in this simulation. Here we are measuring the voltage. So currently, if I step, then you will be able to see the simulation. So now the voltage across the capacitor is this much, which is very less, and the voltage across the battery is this much, which is around 400 volt. Okay, so our main objective is to maintain a current which is very low. So here you are able to see, because of this 50 ohm resistance, we are getting a 7.67 amps of current, which is a kind of very low value which the contactor can handle. With this, the current is flowing. So you can also see, as the current is flowing, the capacitor voltage will gradually rise over the time. So it is rising gradually. So when it reaches the near voltage, like when it is going more closer to the source voltage, then it is a kind of like reducing the current, because the voltage difference is now less between those two components, like the source and the capacitor. And here we are almost close to the source voltage. Now what we can do, we will just step little bit further. Okay, so we now reached around a stable value. Now what we need to do, we need to change this. So pre-charge circuit will be opened, continuous circuit will be closed. Okay, then if we step, then you can see current is not rising much, it is also settling down. So in this case, what we seen, like current is not going beyond 9 amps. So which is a kind of feasible scenario for the contactors to handle, and there will be no high current flowing in the circuit. So suppose we are not using this pre-charge circuit, then what will happen in this scenario? If we just stop the simulation and now we keep this as 0 as it is, so we are not operating the pre-charge circuit. So this part will not be considered in this case, and we will be only closing this main switch directly. So you can see like how much current it is getting at the beginning. Okay, so if you see, we are getting 198 amps of current. So this is a very high amount of current that is not possible for the contactors to handle. And at the moment when the current flows with this amount, then there will be definitely, while switching, there will be some spark that will happen. And because of this, the contactor may weld, or it will get heat up and get welded to the uh, like the C part will be welded to the S part, and then it will not be operable furthermore, and then you will lose the entire behavior or entire components that you are using for this particular charging method or pre-charge method. As we already discussed in the previous video, that in our case, like that this is the case where the battery is getting discharged. So this is the battery and we do have loads. Okay, so in case of charging process, so we do have this as the our supply voltage, and we will have a battery which is of low voltage in this end, along with some inverter and capacitor and inductor. So those will be connected, and because of this, the same principle is applied in the same scenario, where we have high voltage here and low voltage here, which is the same case here. And it is somehow the similar case that you will get. But the concept wise, if you see, the main objective of this particular circuit is to prevent the high inrush current, so that you will keep your devices safe and you will operate it safely. Once it is reached to a safe state, then you can operate it in normal mode. So that is the role of a pre-charge circuit for a high voltage battery. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to answer your query. So have a great day. Happy learning MATLAB. Thank you.